Hello, geometry students, and welcome to lesson 514, where we're going to be talking about applications of the trigonometry that we've been working on. So if you notice throughout this chapter, you've developed new tools to help you determine the length of any side or the measurement of any angle of a right triangle. Trigonometric ratios coupled with the Pythagorean theorem give you the powerful ability to solve problems involving right triangles. Today you're going to apply this knowledge to solve some real-world problem situations. As you are working with your team on the problems below, okay, we're going to talk about this. Make sure you draw a diagram. So we'll go through and we'll talk about this, but generally, right now, you should be able to solve any right triangle problem using either trigonometry or the Pythagorean theorem, okay? So if we take a look in 537 here, the Bungling Brothers Circus is in town and you're a part of the crew that is setting up its enormous tent. The center pole that holds the tent is 70 feet tall, and to keep it upright, the support cable needs to be attached to the top of the pole so that the cable forms a 60-degree angle with the ground. And then they ask you some questions about it. So as we take a look at this, the first thing we need to do is we need to draw a picture of what's going on here. So first thing we're going to do is, I'm going to draw that picture. So there is my pole there. We're going to call that's 70 feet. Okay, and there's a support cable that's coming off that direction, and this basically is the ground then, is the idea. There's my right angle, so we know we got a right triangle. And it says that the cable needs to be attached to the pole so that the cable forms a 60-degree angle with the ground. So if this is the cable and this is the ground, the 60-degree angle they're referring to is right here. That's your 60-degree angle. Okay, so there's the information that we have so far. So now in part A, they ask you how long is the cable. So again, you got to remember, this is the cable, so what they're asking you is that right there. They're asking you for x in this case, okay? So now, if you take a look at this problem, we take a look and we try to figure out, how do I solve for x? So the first question should be, can I use the Pythagorean theorem? Because if you can, that's usually the easiest method. In this case, I do have a right triangle, but I do not know two sides, and therefore Pythagorean theorem is not going to work. So that tells me I need to use either sine, cosine, or tangent. So as I take a look at this, if the 60-degree angle is the theta that I'm using, 70 then is the opposite leg to the 60-degree angle, and x is the hypotenuse. So if I'm working with the opposite leg and the hypotenuse, opposite and hypotenuse, if you remember back to SOHCAHTOA, that's the SO part of SOHCAHTOA, which means this is a sine problem. So we're going to set up the sine of my theta, 60 degrees, put it over 1, equal to the ratio of opposite to hypotenuse. So in this case, 70 over x. And now at this point, we're going to go through and cross multiply. I get x times the sine of 60 equal to 70, the other diagonal. Now, x is not by itself yet, so I need to solve for x, which means I need to divide both sides by the sine of 60 degrees. Divide by the sine of 60. Those will cancel out. X now is by itself, and therefore, now I can go through and grab the calculator and type this into the calculator. So 70 divided by the sine of 60 degrees equals approximately 80 point, it's 829, so that's closer to 83. And in this case, we're in feet, and this is an application, so I'm going to put some units on there. This is 80. That cable needs to be approximately 80.83 feet long in order to make a 60-degree angle with the ground. Okay? So we were able to use sine in this case to solve for that. Now if you take a look at part B, it says how far from the pole should the cable be attached to the ground. So now what they're talking about back up here is they're saying, here's the pole, there's the ground. If I call this y, they're asking you for that part. And so ultimately at this point you now have, let me give you a little bit more room here, you now have two ways that you could solve for y. Now I technically do have two side lengths, so I could do the Pythagorean theorem in order to find y. I'm going to stay away from that though, because now this is a rounded answer, and I want to try to stay away from using a rounded answer in a calculation. The only place you want to round is the is the final answer. So I'm not going to use that. So instead, I'm going to come back and do some more trigonometry. I once again am going to use my 60-degree angle. 70 is still the opposite leg, but now y is the adjacent leg. So if we're using the opposite leg and the adjacent leg, that is a tangent problem. So the tangent of 60 degrees over 1 equal to the ratio of opposite leg to adjacent leg. That's 70 over y. And now we can go through and I can cross multiply. Y times the tangent of 60 is equal to 70. I can now divide both sides by the tangent of 60 in order to get y by itself. And therefore, now y is by itself, so I go to the calculator and I type in 70 divided by the tangent of 60, and I get an answer of approximately 40 point, if we round correctly, 40.41 feet is what's rounded to the nearest hundredths. Okay? So in this case, like I said, you could have used Pythagorean theorem and it would have come out pretty close, but it's a little bit more accurate because now I did no rounding in the problem. The only rounding I did was the answer. So here's an application of where we could use trigonometry in real life. Okay? If we take a look at one other type of problem here, notice Forrest needs to repaint the right side of his house because sunlight and rain have caused the paint to peel. Each can of paint states that it's going to cover 150 square feet. We need to help Forrest decide how many cans of paint he needs to buy. So we've already got the picture here, okay, and we're going to try to find the area of the painted region. So if we go through and we're trying to find, we don't have an area of this, so we need to break this into pieces so that of something I do have the area of. So what I'm going to start with is this. I'm going to break this right here, which means this then is 90 degrees. Okay, I know that this is 8 as well. And therefore, that 126, if I take away the 90 degrees, that means this angle up here in the triangle then is a 36-degree angle. Okay, and so now in order to find the area of this rectangle, I need to know the length. So I need to find this piece. In order to find the area of the triangle, I also need this piece because these two legs are your base and your height. So kind of the same idea as the last problem. I'm going to call this piece x, I'm going to call that piece y, and now we're right back. The real focus that I'm looking at here is I'm focused on this right triangle. And if I can find x and y, I can then go ahead and find the area to this problem. So let's go ahead and let's do that. Let's start with x. So if 36 degrees is the theta that I'm using, that's going to be my theta. X is the adjacent leg of that right triangle, and 9 is the hypotenuse. So adjacent and hypotenuse, that means that we have a cosine problem. So cosine of 36 degrees over 1 is equal to adjacent, the ratio of adjacent to hypotenuse. Cross multiply, I get x equal to 9 times the cosine of 36. And now x is already by itself, so I can type that in, 9 times the cosine of 36. I hit enter, and we get approximately 7.28 for that length. Okay? So now, at this point, I have enough information to find the area of the rectangle. I can take my base times my height. Okay, my length times my width. I can multiply the dimensions. So 7.28 times 8 gives me an area then for the rectangle of 58.24. That's my rectangle area. Now I need to go through and find y. So now y is the opposite leg of that triangle. 9 is still the hypotenuse. So opposite and hypotenuse, this is a sine problem. So sine of 36 over 1 equal to the ratio of the opposite leg to the hypotenuse. And now I can go through once again, cross multiply, I get y equal to 9 times the sine of 36. Y is by itself, so I can type this into the calculator. 9 times the sine of 36, we hit enter, and y is approximately equal to 5.29 if we round it again to the nearest hundredths. So now if I come back up to my picture, x and y in my picture are my base and my height of my triangle. So now I can take base times height, divide it by 2, and I'll have the area of my triangle. Okay? So 7.28 times 5.29 divided by 2 gives me an answer. The area of that triangle right here is approximately 19.26. There's the area of the triangle. So the total area, if I add those two pieces up, 19.26 plus 58.24, gives me an answer of approximately 77.5 square meters. Okay? There is the total area that needs to be covered on the side of that barn. And so now, in part B, it says assuming that Forrest can only buy whole cans of paint, how many cans of paint should he buy? And notice it says 1 square meter is equal to 10.76 square feet. And remember, if you come back up here, 1 can of paint covers 154 square feet. So now we've got to do some conversions here. I need to get my answer first into square feet, then I can figure out how many cans to buy. So if 1 square meter equals that 10.764, I'm going to come down here and I'm going to take 77.5. That's how many square meters I have. And I'm going to multiply that by the 10.764. Okay. So 77.5 times 10.764 equals 834.21. That now is square feet. Okay, so now that's the total square footage of this wall of the barn that they're looking at. And every can of paint that I buy can cover 150 square feet. So now I need to take that, divide it by 150, and I will end up with my answer. If I divide by 150, I get an answer of approximately 5.5614, which means if I need 5.5614, that means I need a total of 6 cans of paint in order to cover that. So this, again, is kind of a real-life type of scenario where later in life you're going to have to paint walls and houses and things along those lines, and you're going to try to figure out how many cans of paint you actually need to cover that. And so here's an example of where if you find the area, you can figure out that concept. So this will take you through that general idea. Okay, so hopefully this made some sense. If not, bring those questions with if you're not quite sure what I did in some spot. Here's a math notes box. If the inverse trigonometry was not making sense to you, this is, remember, inverse trig is what you use in order to find angle measures. So if you were still struggling with that from the last lesson, here's kind of a summary. They give you a picture, they kind of give you the work and show you how it works. So take a look at that if you're struggling with when to use or how to use inverse trigonometry. Otherwise, here is your practice to learn, 541. So it's from section 514, 541 to 546. However, you can skip both 542 and 545 in this one. Good luck. Hopefully that made some sense. We're going to go over some more application problems in class, and we'll go from there. Good luck, everybody. Hope it goes well.